Hello everybody, welcome to another deep sky and tour of the universe with Brian, and we're showing right now the live GOES satellite, and it's showing some problems down there in the border. You can see here that you're getting some clouds from Mexico. That's Arizona, and that is New Mexico. And I'm in Michigan, but the telescope is located right down here in the boot heel of New Mexico. And so as you can see here, we got some border crossing clouds coming up across the border there. And so I'm going to dispense with my introduction and a lot of the background. We'll get to that a little bit later. Yeah, this is really kind of bass-ackwards because in Michigan it's beautiful tonight. It is totally clear outside my house. But these things happen. The show's going to go on, so I want to dispense with some of the introductory things. We'll go back to those, and you'll be able to text your questions into the chat there. But I want to try to get to Venus because it's one of our closest planets that we're next to. We're going to want to take a look at that. So what I'm going to do here is I'm going to show you the live telescope view there. There's the live telescope, as you can see. And what you're looking at on the screen here is the telescope's control computer. This is a picture of the sky as it is right now. The yellow circle shows what we're pointing at. So if we want to go down and point at Venus, we click on that. We click on Venus and then watch the telescope move. It's on about a 5-second or 10-second delay there. You'll see it. There you go. It is moving. And so we will go over to the camera. The camera is located on top of the telescope right there. And we'll turn the camera on and we'll hit a short exposure. And Venus is a kind of a twin planet to Earth, but it has a greenhouse effect, so it's very, very hot. And so here is a kind of a close-up picture of Venus, and it's kind of blurry because there's a lot of atmosphere out there tonight, a lot of clouds. But one thing that's interesting is that it's not a circle. It's more of like a half moon. And Venus exhibits phases like the moon, and it's the weirdest thing. It's because Venus is inside our orbit around the sun. Venus is closer to the sun than we are, so it exhibits those phases. So we're only seeing about 2/3 of Venus get illuminated there. I can zoom in, but it's not a great picture. This telescope that I have there, as you can see, the black tube there, it's made for deep sky objects and faint things and distant galaxies. It's not really made for planets, although we can get a pretty good picture of some other things. So I wanted to start this tour of the universe with things that are close by, and then we're going to go with things that are further out, and hopefully end the evening with something that's way far out, maybe another galaxy like Andromeda. But the clouds have to allow us, and like I said, the clouds are looking worse and worse. So that's why I wanted to get right into it tonight and not waste any time with any introductory stuff. We'll get into that later. So what's the next planet we want to see? We want to see Jupiter. Jupiter's up there tonight. If you peek out your window tonight, look straight south, it's out there. If there's no clouds, you can see Jupiter. It's the brightest star, straight south at this time of night. So this is Jupiter, and it is the largest planet. And if it was a whole lot bigger, I heard one time that it would be a star. It would have turned into a star, but it just didn't have enough mass for it to have that fire turn on, the fusion, and turn into a star. So it's just a planet. And so as you can see, Jupiter has these nice cloud bands, as you can see. And Jupiter, just like me, is a little bit wider in the middle, a little bit fat in the middle, and it's because Jupiter rotates so fast. It's not because Jupiter eats a lot. Jupiter rotates so fast that it bulges in the center. Jupiter is huge, many times bigger than the Earth. We could fit hundreds of Earths inside Jupiter, but it rotates so fast it bulges at the middle, and it rips the clouds in lines. So you can see the clouds are lines there. And so Jupiter has the really cool cloud belts, and I don't see the red spot. I can kind of see a whitish spot right there in the center, upper center. So we're seeing some things there, maybe a little bit of a white spot here. So, and what's really cool about Jupiter is that it's got those beautiful set of 4 moons. So what you have to do to take a picture, we're just taking live pictures with a Canon camera here I'm just controlling the camera. I'm going to put it on a 1/10 of a second at this setting, and we're just going to take a picture. Now we've got, well, overexpose Jupiter, but now you can see its moons. So I'll zoom out a bit. There. So there's Jupiter, but there's 4 moons. And it is so cool to see these moons from night to night. They go around the planet, and night to night they change positions. And that's one of the coolest things that you can see. And believe it or not, you can see these moons with your binoculars. So tonight you can go out with your binoculars, point there at Jupiter, straight south, and you'll see these little dots. Maybe not the inner ones, but certainly these outer ones. You can see it in even low power, let's say 7 power binoculars, you can see them. Even small binoculars. It's really, really amazing. So these are called the 4 Galilean moons, and they're big ones. That's probably Io and Europa, Ganymede, and Callisto. I could have gotten the order wrong. People will probably correct me in the chat because I did not check my sky chart before I got on tonight. But so that's Jupiter. And so what's the next planet out from Jupiter? Anybody tell me? Okay, some of you got it right. It's Saturn. So we're going to go to Saturn, and this is what we call our oh wow object because everybody loves Saturn. And when I was practicing last night, 2 nights ago, I was looking at the best exposure was a 400th of a second. So hopefully the clouds will not get in the way, and we'll see Saturn and its spectacular rings. It's my favorite. There it is. So luckily the clouds are allowing us to get a pretty good image there of Saturn. Yeah, so there you go. Saturn is the oh wow object. I've been showing people the sky for about 48 years now, and it's amazing how people, when they look through a telescope and they see this, they just go, oh wow. So it's the best thing in the sky, in my opinion, and that's how I got hooked on it. And so now Saturn has a lot of moons just like Jupiter, probably dozens and dozens and hundreds. Well, what's a moon? I mean, is a bowling ball sized chunk of rock, is that a moon? But if we do this overexposed method again on Saturn, you're going to see several of its moons. And I did not look at my phone to see which is which, so I won't be able to label them for you, but you will see them. And I can tell you which one's Titan, which is the largest moon in the whole solar system. We're going to see that here in just a second. We're just taking pictures. And so this is an overexposed Saturn. And the brightest moon right here is Titan. And it is bigger than our moon. It's not a whole lot smaller than the Earth. And they think it has an atmosphere and frozen sea, perhaps. And so Titan is a huge moon, and like all the rest, these all go around Saturn. And there's 1, 2, 3, 4 total moons we're seeing around Saturn. Now, if I zoom out, let's see if we can see any more. Probably not. Anyhow, but that's still pretty cool. We're seeing those, and like I said, if you come tomorrow night, we'll do the same thing, and I bet you that these moons have moved like up. The moons that are inner go faster, and the moons that are outer go slower. So tomorrow night, Titan will only move a little bit, but this guy in the middle will probably go halfway around. So that's the moons of Saturn. Maybe the clouds will allow us to see the most distant planet, but it got demoted. Pluto is no longer a planet. I know that's very disturbing for a lot of people, but it's now a dwarf planet. So let's go to a 5-second exposure. And Pluto is so far out there that the light takes like 5 or 6 hours to get here. So that's just amazing to me that, light travels pretty fast, but the light from Pluto takes like 5 hours to get here, and that's just amazing to me. So this tells us how far we're off for just a little bit in accuracy tonight. And so I can tell you that this right here should be Pluto. And not very exciting. But you can say, tell your friends, I saw Pluto last night. And there it is, right there. And it's in the sky, and it's 15th magnitude. Pluto is so faint that you need a big telescope to see it with your eye. Very big. And the telescope I have is not huge, but we're using a camera, and the camera can store up light. It can collect those photons, unlike we can with our eyes. Our eyes don't collect. We just see photons, and they come and they go, and then we see the next one. We see the next one. But with the camera, it's kind of like a bucket catching rain. It catches those light photons and just keeps catching and catching and catching. And this one, it caught for 5 seconds. So that's why we're able to take a picture of something so far away, billions of miles away, is Pluto at the outer edge of our solar system. And so that's Pluto right there. So that is some of the cool things we've seen. So that's about as far out as we can get with our solar system. And I was thinking that we might be able to see a comet, but I'm just worried about those clouds. Let's take a look at there's the telescope. You can see the observatory. There's other telescopes in the building. The roof is gone. I'll show you a video of the roof going away here. But I want to just revisit the let's look at the clouds here. They are getting worse, but slowly. This camera allows you to find the telescope's control allows you to find comets. Let's see if we can find a comet. I'm using the coordinates from 2 nights ago, so it might actually be gone by now. But what the heck? We're gonna try to see, and if we fail, don't yell at me. I didn't have a lot of time to get ready because I just thought that the clouds were going to be horrible tonight. I didn't think we'd see anything, but you know they're holding off long enough for us to at least get some of our tour of the universe done. So this comet is called Comet K2 Pan-STARRS. It was taken with the Pan-STARRS telescope. I think that's in Hawaii on a mountain there. And oh, there it is. Okay, this little fuzzball. See, it's kind of a little fuzzball right there. Let's go longer exposure here. Let's go to a 30-second exposure and really crank up the gain. And that's the sensitivity of the camera. We're really going to crank it up. We're going to go for 30 seconds. But a comet is one of the coolest things in the solar system because it's a dirty snowball. It's whipping through. It's an interloper. The comets whip around the sun, and then they go back where they came from. And they might come back in 76 years, like Halley's Comet, right? But this one I was studying up on, and this one has never been here before. It will never come back. It's on a one-way trip and in and out and never to return. So that's kind of cool. This one's never been here. And when comets come that have never been here before, we don't know how to predict what they're going to do. So they're very there. Now this is going to be much nicer shot. You got a star. Of course, that's just a regular old star. And I know for a fact that this is a galaxy there, that fuzzy patch there. But this is the dirty snowball. And this is Comet K2 Pan-STARRS. It was discovered about 4 years ago on top of a mountain in Hawaii. And I believe the telescope that it uses is helping us look for space rocks that may come and hit us and kill all life as we know it. So kind of our global defense telescopes, I think. And so they're always looking for things heading in towards us. And this comet here is heading in towards us, but it's not going to hit us, this one. And it's just going to go around the sun, and then it's going to go back out. So that's kind of cool. I'm surprised we were able to see Comet K2. And so that is something that it goes through the solar system. It whips past the Earth. It goes around the sun, and it heads back out and way past the orbit of Pluto. This one, like I said, will never come back. We don't know where it's going to end up. They call it the Oort cloud, and that is trillions of miles out. And we don't know a whole lot about that, but this one is on a one-way trip. So that's the end of our solar system in this tour of the universe. Now we have left the solar system, and so then what do we come to in our spaceship as we go out from the solar system? We come to a nearby star. So let's go to a nearby star. It's 25 light years away. This is a close-by star called Vega, also pronounced Vega. I've heard people say that. That's a little odd, but I think that might be the more correct pronunciation. But when I was a kid, it was called Vega. And so this one is a super bright, close-by star. And we'll just take a 2-second exposure of it. And I want to remind folks you're able to chat. And after about 30 seconds, I will see your whatever you type in chat if you've got any questions, comments, heckling, whatever. And so this is Vega. And if it's clear at your house, you go outside right now. It's that bright star straight overhead. It's 25 light years away, meaning the light left this star 25 years ago on its way here. And that's a close star. And this is bright, bright, bright white star. It's hot, and it's close by. And I can go zoom out here and just show you it's a very, very pretty star and a nice star field there. And so it's a nearby star. It's very bright and it's close by. So I wanted to show you that. So in our tour of the universe, we've seen a star close by, but I wanted to show you where do stars come from, and maybe let's try to see a place where the stars are being born. And so now we're going to go to the Eagle Nebula, and this is a place right now where stars are being born, and hopefully the clouds will allow us to take a picture of this, because the lower in the sky we go, the better chance the clouds have to eat whatever we're taking a picture of. So hopefully we're not going to have an issue there. But I didn't show you the you can't see the picture of the telescope there. Now you can see the telescope pointing. Shortly, I'm just gonna shut it off, because there's a night light that shines on the telescope. It's an infrared light, and it illuminates the night vision of the telescope, or allows us to see it. But the downside is it kind of the light is going down that tube, as you can see that, and so I had to turn the light off, so we won't be polluting our shot. Okay, now this is a very nice shot of the eagle. If I go full out, I can show you. This is the eagle's head. There's a wing going this way and a wing going this way, and this is the body. And so that's why they call it the eagle. So longer exposure shots, you see a better and better picture of the eagle. But it's also a very, very cool place where stars are being born right now. And the stars are being born inside these dark areas, like these little cocoons there. These little dark cocoons are where protostars are being born right now. This is also called the pillars of creation, and this is the famous Hubble shot showed these 3 fingers. And the really cool thing is if you zoom in on this finger, there's a little baby star at the tip of the finger. We might be able to see that. Right there, and also right there. So that's the Eagle Nebula, and it's really cool. And so I can use my tweaking methods here to kind of emphasize. So I'm kind of emphasizing with my little tweaking buttons on my program, but that's where stars are being born. And so stars are born out of gas clouds. This is a cloud of glowing gas. It's hydrogen mostly, and it slowly collapses and gets denser and denser and denser until the fusion turns on, and suddenly it's a star, and it lights up and uses nuclear fusion. It puts atoms together, and when they do combine, then they create tons of energy. And so that's how a star puts out so much light and so much heat, by nuclear fusion. So this is the Eagle Nebula. which is also M16, Messier number 16. And I'm really happy we're able to see this above the cloud bank.
Wow.
There's another place where stars are born nearby. Let's see if we can catch that before the clouds eat that. And it's called the Swan. It's right next door. So take a picture of that. And as I said, red means hydrogen. Red means glowing hydrogen, and it is that's where stars are being born. And so it takes a little while, but stars are being born right now in our galaxy all the time. And we're seeing things that are only in our Milky Way galaxy right now. We have not left our galaxy. We will see a lot of good things in our galaxy before we leave it. The last thing we're going to see, hopefully, is another galaxy. So this is going to, I have it ahead of no magnification there. That's the whole frame of the Canon camera. All right, this is the Swan. I wonder if I flip her around if it looked more like a swan. Yeah, I think this way. Yep. There's the tail of the swan. He's swimming, and there's his head kind of like that. So beak right there. Maybe that stars his eye, the neck right there, and then there's the body of the swan. And there's all this gas back there. Maybe the swan is passing gas. I don't know. But this is where stars are being born right there inside this chunky. See how chunky it is? It looks curdled, and this is where there's massive cataclysmic things happening there as stars are collapsing. The gas is collapsing, forming stars, and then once the stars turn on, then they blow a hole in the gas. And so lots of fun things happening there. The camera I have is a Canon 5D Mark III camera. It's about 12 years old. The shutter has fired 10,000 times, but it has been slightly modified to be more sensitive to red. A little bit more sensitive to red than our eye. And so it's a minor modification, but it allows us to really see these places where stars are being born, because I really enjoy taking pictures of these, and I enjoy it so much that my license plate used to be Nebula. But I did give that up a few years ago, so I no longer have the Nebula license plate. I just didn't like paying the $180 a year, I guess. I don't know. But I had to turn it in, because I got a different vehicle. That was the reason. But that's the Swan, or M17. So when stars are born, they're born one at a time, but sometimes they're born in a huge cloud, and a bunch of them are born together. So let's take a picture of a bunch of stars that were born together and have been living for a few million years. So this is a star cluster, and it's called the Wild Duck Cluster. And like I said, it's where stars have been born and living for a while, but they're a cluster together. And so we'll go that there. And let me go back to the chart. And we are looking within the Milky Way. It's kind of diagonal across the sky. The Milky Way is at its best time of the year right now. This is the best time to see the Milky Way. If you can get out to a dark, dark place, get out. And so you can see the Milky Way. Get away from those city lights, because it's straight overhead. This is the best time of year by far. And this object is also a blast to see in a little telescope, and it's called the Wild Duck Cluster. And for some reason, I am not precisely aimed at it, but hey, it works. You can see it. Now, I'm not sure why that he called it the Wild Duck Cluster. I think it was an astronomer in the 1800s, Admiral Smythe, perhaps, who named it the Wild Duck Cluster. His telescope was obviously not very good. When he looked through the eyepiece, he saw a flock of ducks. I don't see a flock of ducks here, but some have said, well, it's a kind of a V shape. There's a kind of a V shape to it, and that looks like the V shape formation of ducks flying, I guess. But anyhow, it's a very nice star cluster, and so if you look at it in a small telescope, this is what it looks like, or a big pair of binoculars, this is what it looks like. Very cool. And then as you get more and more power, you see, oh, I can see individual stars. And so we zoom in, we can see all those individual stars. and they were all born together, and they live their lives together. They drift apart, just like people, and but they don't go that far away from each other, and that's a star cluster. We don't have a star cluster around our sun. We're all by ourselves. So that's just the way we are. But star clusters are a lot of fun, and so these stars are kind of towards their middle years of living. And we're doing well on seeing things. So maybe I could point to another star cluster. And this is one that is, they're more jammed together, very, very highly compressed.
I want to take a break. Make sure that people can actually see you and hear you. Kind of have somebody check in.
Yeah, and I want to make. I believe that I'm putting out good audio, so people type in the chat if the audio is good or if I need to turn it up. I definitely want to hear from you as far as how the audio is working and the video, or if anything I need to tweak, let me know. Because now we're going to look at the Great Hercules star cluster. If you saw the MLive article at noon today, they had a highly magnified picture of that. And thank you, Greg, for telling me that I'm good. And Matt says there's something on my head. And yes, this is Matt. This is probably your first time watching one of my YouTubes. I always wear a ridiculous hat. That's just my mojo.
It's a handsome hat.
It's just a wild. I wore a cheese head one time. I had it's always a crazy hat, and I've got a really amazingly ridiculous hat for my next session. But anyhow, today this kind of, remember, if you're old like me, you remember the old margarine commercial?
Yeah.
Ta-da! Right? Okay, this is my margarine. That anyhow. Imperial. Thank you. That was my lovely assistant. She's helping me with the chat. And she's going to be telling me, she hits me on the shoulder if there's something I need to pay attention to in the chat. But this is a way cool star cluster. It's called the Hercules star cluster. And I'm just going to, we're going to crank it up. There we go. It's a ball of stars, that is about a 250,000. 250,000 stars in a ball. And I have read, I don't know if it's true, that if we lived there, we would not have night. There are so many bright nearby stars, each as bright as the full moon, all over the sky, that you would never have night. So that is the Great Hercules star cluster, and it's just one of my favorite things. And if you look at the mlive.com, they have published a picture of this where it was color, and I really cranked the color. I really turned up the volume on color, so it's a highly color intense. What's really kind of cool is that there's some nearby stars, which might become an orange. Orange means older star. Okay, when stars are born, they're hot and blue, and they get old, they turn red and get cooler. And that's an older, cooler red star there. Versus these stars here are not quite as red; they're more golden. And there's another star there, and that's more white. But what is kind of fun in this area, I think there's a little galaxy, far, far away, right there. And so that galaxy is thousands of times further away than that star cluster. Thousands of times. But we'll hopefully finish our evening with a galaxy, a better one than that crappy little one. But this is the Great Hercules star cluster, which is roughly 15,000 light years away, relatively close in our Milky Way galaxy. So we saw stars being born, we saw stars clustering up, and so the next step is stars dying. So in our tour of the universe here, we got to go to the end of a star's life. We're going to go to a dying star nebula, and this one is called the Ring Nebula. And so I wait until the telescope finishes moving, and then I hit go, and it's going to take a picture. And so this star has died, and you can see, well, it is dying, and it's left a shell, a bubble, hot bubble of gas around it. And we're going to be able to see that bubble, and we're looking through the bubble. And when you look through the bubble, you see a ring, and it's called the Ring Nebula. And this is one of the fun things to see in your telescope at night, because you can actually see this in even a small telescope. You can see this. Now you can't see the colors. All right, not going to see any colors, but you can see the structure here. And you won't see the central star like we are, but you'll see the nice ring. So this star in the center is exhausted its fuel, and it's puffing out a hot shell of gas. That hot shell, that bubble, is expanding and poofing out and diffusing. And so this is one of those objects that changes. And people always ask me, well, hey, that's you say that's hundreds of light years away. And I said, yeah, okay. Well, is it still like that today, even now? Because the light took 400 years to get here, okay? And usually I say, no, things didn't change. Things in space don't change. But this is one thing where things do change. So in actuality, I would bet you that the bubble has grown in real life, in real time. But we are looking back in time, right? A telescope is a time machine. We are looking back in time, and we're looking the way this looked 500 years ago when the light left there. But it's called the Ring Nebula, and it's a dying star nebula. And so that's a very interesting one. There's another one close by that anybody with a telescope also looks at, and it's called the Dumbbell Nebula. It's not named after a person. It's named after somebody thought that it looked like a dumbbell. But to me, it kind of looks like, it looks like an apple core if you use a telescope. But when we're going to look at it, I think it looks like a football. And this football season right now, so we're thinking about football. There's a lot of football games on tomorrow. Badgers against Notre Dame at noon. All right, there's the football. That's the dumbbell. And you can see the football shape. And you can see the star in the center. This is the one doing the dying, right in the center there. It's puffing off this gas bubble, and it's interesting. This one is of multiple colors. It's got the greens and the reds, and that's different gas, and it's different excited electrons. And I cannot remember, but I do think green is more like oxygen. Red is more like hydrogen. Nitrogen also can be green. I'm not sure of that, but this is a fascinating object. It kind of looks like a balloon with the two ends blowing out. But and you can see it's much bigger than the ring, which means it's been expanding longer. The ring just started to expand, but this one has been expanding for more millions of years. This type of object is the way that our sun is going to die. Our sun will start puffing off its atmosphere, and it'll be a hot shell of gas that will envelop Mercury, then Venus, and then Earth. And so when that hot shell of gas hits Earth, we are burnt up, and any life here is gone. But we have a couple billion years until that happens, so we don't have to worry about that. Since we're nearby, we can look at something interesting, because it is the case that 40% of all stars are doubles or triples. So it's fascinating to me that 40%, definitely a third of all stars are double stars. And so our sun is only a single. But I'll take a picture of, this is one of the most famous double stars in the sky. It's called Albireo. It's the end of the tail of the swan. And this is the typical picture that you'd get by looking through a telescope. And if you raise the power of the telescope, you'll see this. And we're not really doing this justice, because when you look through a telescope, it's a yellow and a blue. They call this the Michigan star, maize and blue, or they call it the Cub Scout star. It's got the blue and the yellow. So it's a very beautiful object, and maybe if I turn down the exposure and the sensitivity, we'll kind of get a better look at the colors, because the blue is really awesome, and they're very contrasting. Right? They contrast, and so you're starting to see a little bit there. But anyhow, that's called Albireo, a very beautiful double star, which is almost perfectly overhead. Look at that, almost perfectly overhead at the tail of the swan. And also they call it the Northern Cross right there. And in this star chart, N is north, that's north. West is over here. East is over here. South is over here. And things are moving that way towards the west. And this is pretty much the same sky as we all are seeing in the United States tonight, with a small change from east to west. This also shows those interesting objects that are little green circles. And we have a question from Charles Steen Carter. I just joined, was watching another YouTube presentation. Loving this one. What is the bright red star to the left of the dying star? Well, we can go back. And we did have some. There's a bright red one right there. That's it. And it is just a regular old star. Nothing special. Nothing special.
They're all special.
There's nothing special about that star. That's a star that's probably 1,000 light years away, and it could be a red dwarf. A lot of stars, most stars in the Milky Way are dwarfs. They've gotten old and they've shrunk down, and they're more orangish, and that's what this one is. And let's see, was there anyone by the ring that was red? Well, maybe he was reacting to this one there. Well, this red star is extremely interesting. It's an artifact of the camera. That's no star at all. See the blue star right there? As cameras get older, they have artifacts. And like I said, this camera has taken over 10,000 pictures. And so as cameras get older, pixels go bad. And so the red pixel there stays on. No matter what happens, it's just staying on. So these pixels get sick, and that's a sick pixel. So sorry, it's not a special red star, although some stars are almost that red. It is just a sick pixel, and there's nothing I can do about that. Well, when I take pictures, I can cancel those out, and I do that. So there's a way to cheat. But you are seeing the unvarnished, unwashed, unprocessed pictures. These are straight, raw as they come out of the camera.
He was talking about the one closer. Remember there was one closer?
There was one closer? A dead pixel?
No. A little star. Back in the other one.
Oh.
It's okay. Don't worry.
All right. So yeah, but you'll see as we go through this. You'll see some sick pixels. So we've seen some stars are born. We saw some star clusters. We saw some double stars, and we started to see how stars die. And the way that's the way we saw stars die, where they have the bubble, and we saw two bubbles, and those are stars that are average size. So when an average size star dies, it just kind of has this bubble and puffs out, and then it just snuffs out, and it's done. When a star is big, it explodes in a kablam, and that makes a shock wave that goes across space like faster than a bullet. And we're going to take a picture of one of those shock waves that is still moving after thousands and thousands of years after the explosion, the cataclysmic explosion of a supernova. So we're going to take a supernova shot here. And this one is also straight overhead tonight in that northern cross, that Swan constellation, Cygnus. And this, on the other hand, is not something that you can easily see with a telescope. You got to get out where it's really dark. You got to have a bigger telescope. And if you can have a special oxygen 3 filter, it is then good. But this is one of the tough things to see because it's spread out. It's a bunch of glowing gas that's whipping through space like a shock wave after a huge blast and a huge explosion. So let's zoom out and you can see the entire shock wave. Actually, we're only taking a picture of part of the shock wave. There it is. That's the shock wave. And I'm going to turn down the brightness of the background to hopefully emphasize. I want to emphasize that shock wave for you. So that's the Veil Nebula, and they call it a veil because you can see it's got this filamentary structure, and so this thing is moving from left to right, upper left to bottom right. So it is a shock wave that's moving, well, I don't know my finger, that way. And it's the Veil Nebula, and it was an explosion that happened like 50,000 years ago. And it is moving through space at more than, I think it's something like 10 miles per second. And but what the good thing about a supernova blast is it redistributes all the building blocks of life. Stars are where, and supernovas is where a lot of the chemicals that make up our bodies are spread out, and that's how we are formed, out of those same elements, the higher elements. And so that's the interesting thing about the supernova blast. And so this is called the Veil Nebula, and it's located near the Cygnus the Swan. There are other parts of this, because this you can see the other half of the blast wave. It's just off camera on the upper left there. But it's way cool, and it's one of my favorite objects. And one time at a Boy Scout camp in northern Michigan, I spent a whole night just doing nothing but studying all the different structures within this complex called the Veil Nebula, and it is so cool. And when you have a really dark sky, you can see all the different structures, and it's just really amazing. So this is how stars born. If they are a big star, they go kablamo, and they have a huge blast, and the blast just keeps rolling through space. So that's how stars die, and so that's what happens throughout our Milky Way galaxy. Now it's time on our tour of the universe to leave our galaxy. Everything you see here on the chart is in our galaxy. If you're looking at pictures of the sky, if you just look at the sky, everything you see with your eye is our galaxy. Only if you look in special places can you see another galaxy with your eye. But it's time for us, if the clouds allow, to see another galaxy. And so I'm going to go to Andromeda. And we had an earlier request for some NGC objects in Pegasus, and that was from Gerard Joseph. So maybe while I'm doing this, Gerard Joseph, why don't you text in which NGC objects that you want to see? And Greg had a question about straight overhead. Yeah, things that are straight overhead in New Mexico right now are tilted a little bit towards the west here in Michigan or in Ohio in the Midwest. So we all don't have the same sky in the United States, but it's pretty close. It's definitely not the same as we would have if you were in Australia. That's a whole different sky. So this is Andromeda we're going to be taking a look at. So I'm going to hit a 30-second exposure. And so now we have left our solar system, and we are going 2.5 million light years away. So we're taking a big jump because our solar system, our galaxy, is on the order of tens of thousands of light years away. Now we're going millions. So we're moving from thousands to millions of light years. And it's just astounding to think that this is our closest neighbor, but the light left there 2 million years ago. All right, so what we have focused on is the little companion galaxy of the big Andromeda there. So I want to fix our pointing because our pointing is pretty crappy there. So I'm gonna fix the pointing, and I'm going to put it on the center. So what I've got to do here is I was being lazy and I wasn't being precise. So what we do is we zoom in. We zoom in here all the way, and let's try that one. Nope, right there. There, Andromeda Galaxy. Whew. See, everything's all close together there. So, but we'll play with this while we're waiting. Galaxies are composed of billions and billions of stars. That's the glow. So this is not gas. This light is stars. There's so many you can't see the individual ones. And it's cool that there's these dust lanes. These dark lanes are clouds of dust, huge clouds of dust, and they get pulled in directions as the galaxy rotates. And so this is a spiral galaxy because you can see the spiral rotation. Our galaxy has also got the spiral arms, and we don't see them pretty as well because we're inside. Now we're going full frame on this one. Now you can see Andromeda, its bright nucleus. You can see some of these spiral arms going around, the dark lanes, and it's got 2 companion galaxies, one there and one there. Now we have companion galaxies too, but we can't see them from North America. You got to go down to South America to see them, or the Southern Hemisphere. They're called the Magellanic Clouds. I was planning to take a trip down there to take pictures of the Magellanic Clouds, but then the plague hit, and then I couldn't go. So hopefully someday, that's my bucket list, is to go down to see those Magellanic Clouds, to see the southern stars, because I've never seen the star. There's a third of the sky I've never seen, so I really want to see that. And so what happens if we mess with the brightness here? Can I emphasize things, or am I just making the picture worse?
Oh, well, that's cool.
Well, we're kind of doing some extreme formations here, but you can get the idea. This is just a bunch of stars, and we have these 2
I like that.
two little brothers of this galaxy. So that's called the Andromeda, and it is the closest neighbor to ours. And since we are doing so well, there is it's further down in the sky, but let's see if the clouds allow. There's another pinwheel galaxy, which is, you can see the spiral arms a lot easier. So this is one we're going to point at because it's pointed, the galaxy is oriented in a better direction towards us. And so this one, you can see the spiral arms better. Andromeda is more at an angle, and so it's harder for us to see the spiral arms. But interestingly, Andromeda and the Milky Way are on a collision course. We're going to hit each other, and it's going to be horrible, but we got several billion years to worry about that. So don't have to worry about that. So that's Andromeda, and but we switched over now to a nearby galaxy to Andromeda. These are really neighbors of ours, even though they're 2 or 3 million light years away. Oh, look at that. The clouds, finally, we found the clouds, didn't we? We only went down a little bit towards the east, and we totally found the clouds. So we know now that we can't be getting too low in the sky. So we're going to try to do what Gerard Joseph wants to see, an NGC object. So let's try one of those before see if the clouds will allow. And so we're going to go to, because he's typed this into the chat, and the first one he typed it is 7335. And it's a galaxy. We're going to hit go to. There it is. Now, luckily, that's pretty high in the sky. I think we'll be able to get a picture of that. So we'll go, and 7335 is probably, well, we know it's going to be further away than Andromeda. It's probably in the hundreds of light years away, not just 2 or 3. So very likely the light left this galaxy before the dinosaurs. That's just amazing. The dinosaurs were made extinct about 66 million years ago. So this is NGC, New General Catalog, number 7335. And that's a pretty little, nice little galaxy right there. And look, it's got little ones next to it. Very cool. And I probably have taken pictures of it before, but I don't remember it. But that one is kind of cool. All right. All right. So let's go to the next one. Let's just do one more from that. 7625. As you can see now, it's fun to just zip around the sky with this. Now we're inside the square of Pegasus, the flying horse, the winged horse. See this is called the Great Square of Pegasus right there. And Pegasus is connected to Andromeda. Andromeda has this string of stars hanging off one corner, and Andromeda Galaxy is right there. And it's the furthest thing you can see with your naked eye. So if somebody shows you where to look, you can see the Andromeda Galaxy out if you're away from city lights. It's the furthest thing your eye will ever see. But this is another galaxy, I think, yes, and it's inside the square. And it's probably several hundred light years away, maybe 1,000. That's our pointing accuracy, pretty good. Ooh, this one. That is a faint little galaxy. That's very far away. So number 7625 is very far away, right there. It's just a tiny fuzzball, unless of course the clouds are causing this. But I'm still seeing.
It looks like it's just.
The stars look okay. I mean, look. Yeah. Well, let's click back to the previous one. It looks like there's fewer stars. Yeah, I think we got a little bit of clouds that are messing with us. So I bet you we would have seen this better. So, but I wanted to show you a blazar, but I think it's where it's where a black hole is at the center of a galaxy and causing these huge laser beams to be blasted out towards Earth. And it's very, very, very far away. It is billions of light years away, but I don't think we're going to be able to get a picture of that. But I'll show you an artist's conception of it here at the end. But so I think that's probably what we should conclude our tour of because I want to show you a little bit of my background and some other interesting stuff, unless we have other requests. But so let's, for folks who haven't seen my shtick before, let me narrate that for you. So how did I come to get here? Well, I was probably about 12 in Wisconsin, and I saw a lunar eclipse, and it's like, what the heck is that? So I checked out books from the library, and then I got a little telescope, and then I got a bigger telescope, and I got bigger. People get bigger telescopes until their back gives out. That's what my model is. Yeah, I see it happen again and again. And my back finally said, no, 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 no. And so now I've been getting smaller telescopes. But the light pollution has really gotten really bad, especially here in the Midwest here. I'd love to take the pictures, but I have to go out where it's dark. And so all these pictures were taken out where it's pretty darn dark or away from city lights. And so we just had more and more light pollution. So I decided to move the telescope I had in the backyard. I got rid of the dome. It's now in Ohio at a park. I want to visit that soon. But I moved the telescope out down into the desert, down into New Mexico, because it is dark there, and it's going to stay dark because there's not much development. There's not much water. And look how this is the number of clear days per year. And here in the Midwest in Michigan, it's cloudy. It's like it's almost Seattle cloudy here. And if you go down in the Arizona area, it is sunny all the time. So moved everything, drove it out with the camper out to a telescope ranch. And it's called Dark Sky, New Mexico. It's down near the boot heel of New Mexico. And it's a telescope ranch because they got a bunch of these roll-off roof observatories. These are square. These are not domes. These are just simple sheds where the roof moves sideways on a track, just like your garage door. And so they're automatic. The roof opens if the clouds are not there, and the roof closes if the clouds come, or if the sun comes up, or if rain comes, it automatically closes. So everything's automatic. I don't do any control. I have 3 or 4 neighbor telescopes in the building with me, and we each pay a monthly rent. So everybody here, the 20 telescopes or 30 that are now here, we rent the space. This is what happens when in the evening the roof slides off as soon as the sun goes down. It's a hot day. It's warm. This is at 4,000 feet, so it's not really hot out in this part of the desert. It's not ridiculous like Phoenix. Doesn't get to 110 like Phoenix here. But this is with the roof open. That's my scope on the left. Those are some bigger scopes there. Bigger scopes right there. But mine is very modest. It's a Dobsonian type telescope made in Taiwan. It's been outfitted for photography, so it's got some special stuff. But I have a fancy robotic mount. That's the thing that allows us to do what we're doing. You click, it goes. And as I said, I got a simple Canon camera that was modified slightly. And so this setup is fancy in that it has the robot. And it allows me to take better and better pictures. Over time, you can get better and better pictures because you have better darker skies. Usually that's what it is. So that is the background. And
you have a question.
Oh, there's a question.
So that the
software that I'm using, yes, there's a question about the software we're using. Let's go back to show you what the software is I'm using. Let's pull it down. Plane wave interface. The mount is a plane wave mount, and it was made here in Michigan. And it's a robot. It's a robotic arm, and this is the control software they sell with it, or they give you with the mount. And it's pretty standard. A lot of mounts have the very similar planetarium program. You click, it goes. And it has a database and easy to use. Really, really fun. So that's what I use for that. And then the software for the controlling the camera is called Backyard EOS. It's made by a gentleman in Quebec, I believe, and it's a wonderful program. It's like $50. I'm very happy with it. Very, very, very. It's been wonderful. I've had it for many years. It's been fantastic. So those are the 2 pieces of software I use. Really, I don't use a whole lot other ones other than once I get the pictures home and I want to process them. Well, then there's a lot more software that I'll use to process the pictures. All right. Let's see some other things that we were going to look at. We're doing pretty well. This is kind of encapsulates all the things we were trying to do here. tonight we went from the Earth to the Milky Way to other galaxies. And we started with the solar system. And I took all these shots. I'll tell you if I didn't, but there's a lunar, this is a solar eclipse. And this is when the moon passes in front of the sun. And the amazing thing about our moon is it appears the same size in the sky as the sun. That is a spectacular coincidence. That does not happen on other planets that I know of, is like it happens here. And so we have these amazing solar eclipses. This is the one that was in 2017. And I wanted to talk about this because there's another one coming up in 2024. So in 2024, early April, make sure you have made plans to see one. It's spectacular. It's going to go in the United States. It's rare for us to have one in the United States. We're going to have 2 in the course of 7 years. So make plans to see it. The track is starting in Texas, and it moves north, and it ends up in Ohio. Highly recommend. You see the solar eclipse in April of 2024. Let's see. I got a picture of I got a video of a killer asteroid. This is an asteroid that was whipping past Earth, and it was only a couple moon distances away. It was almost as close as the moon. So let's see. There we go. I'll hit watch. I'll play it one more time. So this is a chunk of space rock that was, it was 1.3 the distance to the moon. It was just a little bit further out than the moon. It was 400 meters in diameter. All right? This thing is as big as a football field. This hits Earth, and it's not good. Not good at all. So that's why we have these telescopes taking pictures of these things on top of Mauna Kea or Mauna Loa, one of the mountains in Hawaii, and just to make sure that we are not going to get hit by something like this, because they're always happening. The more we look, the more we see. So that's something that we always have to watch out for. There's the 3 planets we saw tonight. We saw Venus. It's our twin to the Earth. It's the same diameter as our planet, but it's real hot. It's closer to the sun. It has a lot of atmosphere. It's very hot, like 700 degrees. This is the Jupiter, which is huge, and the red spot, which we did not see. Well, I think we did see some white spots, and then there's Saturn. It's amazing. We saw a little comet, but this was a comet that came real close by. It was called Comet Lovejoy, and it was taken a few years ago, and I took this from the Lazy Boy up north visiting some relatives, which was pretty amazing. It was the first time I took a picture away from home. And the remote control telescope works well with anything, including the phone nowadays. I can use my phone to take pictures. This is our galaxy. You can see it very well where if you go out to northern Michigan or get away from those light polluted areas. The green is a relative of northern lights. It's when the particles from the sun hit our atmosphere and get the atmosphere all excited and glow like a neon light. This is like a neon light glow in our upper atmosphere, and that is kind of rare. The red is from the fires. We've had a lot of smoke from fires, and that's the red from a few years ago from the fires. But this is the best time of year to see the Milky Way galaxy, and I urge people to get out there and see it. Now, this is what we saw earlier. I want to show you this. I want to get out of the way, get my head out of the way. Remember, we saw the 3 fingers. Remember, we zoomed in on this one right here, and we saw a star being born at the tip of that finger. And this is the Hubble shot. And it's just spectacular. You see these little fingers, these little spikes, and there are stars, protostars inside those. All those little spikes at the end here. At the ends here. Right there. Right there. Right there. So this is the pillars of creation, and it's just a spectacular shot, and it's I'm happy to have something that even approximates it. It's not nearly as good, but it's always amazing when you can see something that the Hubble is seeing, and maybe the Webb telescope will be so spectacular when it goes up next year that I'll not even be able to take any pictures that it can see. Who knows? But it's seeing different wavelengths. I think more infrared, and I can see some infrared with my camera. We didn't see this. This is where stars are being born, and this is the Orion Nebula. So you're going to have to come back for a show in November or December, January to see this. But this is where stars are being born. Remember I said red means glowing gas where stars are being born. And this is the Orion galaxy going by, Orion constellation going by. And the telescope is taking pictures all night. So this is kind of an all-night time lapse. And I'll play it one more time. And that's the Orion constellation there. Betelgeuse is right there. The 3 stars in Orion's belt. Now, we did not see this, but we saw a close relative of this. This is one of those dying stars. And we saw the Ring Nebula. It's kind of like this, but this is a slightly different one. It's called the Helix. We did look at this. Remember? We were looking at a slightly different orientation, but we saw the Veil Nebula. We looked at this section right here. All right? And this is that shock wave that's whipping through space at tens of miles per second. So it's really whipping along very quickly. Then we looked at this. This is an Andromeda picture right there. And I just wanted to show you this because this is what you get if you open the camera up for 10 hours. This is a 10-hour exposure. So you're collecting a lot of light, and it allows you to see the colors better. And so that's what you have to do to get a picture. And so what I do is I take 5-minute exposures, and I just keep taking a 5-minute exposure, a 5-minute exposure, and the telescope is tracking very, very well across the sky, and just keep taking 5-minute exposures, 5-minute exposures, and then I will download them and stack them all together, and you get a picture like this. On the left is the Whirlpool galaxy, and what's cool about that one is the big one is eating the little one. Little galaxy was going by, and it got pulled in by its tractor beam. And so that is, and it's in the process of eating it. And once it has digested the little galaxy, the whole thing will turn into this big fuzzball, kind of like a cotton ball. And there'll be no more spiral arms to see anymore. So that's the Whirlpool. We didn't see that. That's something we'll probably see in the spring. And we tried to see this, the one on the right here, the spinning one. That's called the pinwheel, but we couldn't see that because remember the clouds ate that one. So we failed on that one. And we wanted to try to take a picture of this. It's just a dot, so don't be disappointed, even if it was clear. This is a blazar with a black hole. So there's a black hole in the middle of a galaxy, and it is over 10 billion light years away. So very, very, very far away. So if we're seeing it, it's got to be bright. It's one of the brightest objects that astronomers have ever seen. And it's a black hole that's just blasting out these lasers of matter in 2 different directions as it eats everything inside the middle of that galaxy. On the picture in the upper right there is what it looks like. Well, you can't quite see it, but it's not too exciting. We couldn't get a great picture of that. So that just shows you all the things that we were going to see. If there's any other questions. All right. I want to show you a video because of another thing that I've been doing that is kind of cool is I've been trying to do things more in person. Because of COVID, we've been doing things not in person. And so having a remote telescope is a good thing during COVID, because we can have some fun and show things in a safe manner. You can stay home and see some things. But hopefully this all is going to end, and we are going to be able to get together and look at the stars together. And so I've put together a new type of technology which allows us to see the stars and do what you just saw, but in person. So I want to show you that. I have a little a little video that talks about what I'm doing, because what I want to do is be able to put on these shows for people. And the point is that we've got this astrotourism is something that is happening, and people are going to see the stars. And so it is it's definitely something that's happening. And I want to turn the something off here. I turned my face off. Ah, there we go. There we go. Now we're getting somewhere. All right. So, and we can turn off our there we go. So now you're seeing this. So astrotourism is a thing. And these resorts, especially there's a resort in Hawaii that has, in Maui, who has telescope shows up on the roof, and it's booked solid every night. They charge for it. And a lot of these different resorts in the Southwest and California and Arizona, even Florida, they're featuring their dark skies. And so people are traveling because they can't see the Milky Way in their backyard. So I put together this technology with a telescope and a camera, and I can show what you just saw, but in person. And it's a small telescope, and I put it on a 100-inch screen, and we can do a laser tour. I can point out the constellations. Then once it gets dark, we can start showing things on this 100-inch screen. So the same as you saw tonight, I'm narrating, I'm showing galaxies, star clusters, nebulas, and we move from object to object, just spend a couple minutes on each one, and can show these things to folks and take questions. And it's more of an interactive thing. Right now, unfortunately, I'm talking to the screen, so I don't get much feedback from you, but it's more fun to do this in person. So that's what I'm hoping to do, especially in the winter, where it's going to be clear in the west and the southwest and Florida, and not so clear and not so nice here in Michigan. So that's kind of where I'm going here. And so I put together this video to explain what I'm trying to do here, and I'm going to be sending this out to different resorts and national parks to line up line things up for the winter. This shows some of my stuff I got published and being on the radio. So just trying to show people that I'm not a complete boob, and I do know what I'm talking about. And I paid somebody a lot of money. He gave me a nice quote. I worked for him at the summer camp, the Boy Scout camp this summer. And I want to tell the folks that that we can do an in-person show, and people can see stuff they've never seen before, and they can have more reservations in the future. And so anyhow, that's my little promotional video for what I hope to do in the future, which is try to be more in person rather than online. So that's kind of where I see this hobby moving, at least for me. And also maybe putting on workshops to show other people how to take pictures of the sky. So that's another thing I want to do as I have more time and we can have more travel, because COVID is going to be abating. I'm going to go to Saturn, and we're going to see if the clouds are okay. In fact, let's take a look at the radar. This is the GOES satellite. I'm going to hit redo, and it's showing worse clouds. So it's showing those clouds getting worse. So let's see if Saturn is worse here, because Saturn's my favorite. So I'm going to get a picture of that. I have my phone set up so the roof, when it opens and when it closes, I get an automatic notification on my phone. So, all right. So what we just learned was the clouds have definitely moved over Saturn. So let's try a kind of a interesting double star. Well, let's look at Deneb. Let's go to Deneb. I think we may be getting shut down here. Oh, I want to show you the tracking of the robotic telescope mount. This is the quality of the tracking. There's left, right, and up, down, right, and this shows you how accurate it is, and it's very nice, very accurate. It's tracking very well. When we have gusts of wind, you'll see these bounce around, and I'm fine as long as it doesn't go above 1. But once it goes up and starts to go hit and above 1, then I have trouble taking pictures. But tonight there's no wind at all, and we're doing well. And you can see we have a little bit of clouds, but you can see Deneb there, and this is a star that looks bright and looks like it's close by, but it's not. Vega is bright because it's close by. This one, as I understand, is bright, but it's super bright in real life, but far away. Vega was 25 light years away. This one is, I think, 1,000 or several thousand light years away, which means since it's so far away, it better be really bright, and it is. So that is Deneb, and that's Deneb. What else is it going to let us take a picture of tonight? We've got a lot of really cool things to see in the summer Milky Way. It's sad when we have that end of the year and we don't see it anymore. What's it going to take a picture of next? There's another one of these clusters of stars that is 100,000 in a ball. Let's try that. I'm going to put this right back. But it looks like we're going to only try a couple more things. I think the clouds have probably come in and are stopping us from seeing a lot of the things that are far, far away.
You got a lot more in tonight
but
than you thought.
We got a lot more in than I thought. We were able to see all the solar system objects, right? We saw Venus and Jupiter and Saturn, and we saw a comet, and then we saw a nearby star. We saw stars being born. We saw stars dying, and we saw another galaxy. So that was a lot of cool stuff, and yeah, we have a lot of high clouds, so it's really kind of ruining the view here, because this is normally a pretty awesome ball of stars, and right now it's shining through a layer of high clouds. That's the issue we've got going on tonight. So I think I'm going to wrap it up here and let people go and do other things. But I appreciate all the good comments and the nice things people said. And Melinda just said they saw Deneb from their backyard. That is awesome. They used the Skyview app. Yes, Skyview app on the phone. Fantastic. Skyview is great. Sky Safari, also great. I highly recommend people get the app, and then you can point it up to the sky. But something that's important is if the app is a good one, it'll have red light mode, night mode. So put the app on night mode, red light mode, so it doesn't ruin your night vision. Because if your phone is bright and you're trying to see stuff in the sky and it's faint, then you're ruining your night vision. So use the red mode on the phone. But what's really cool about them is you can hold the phone up to the sky and it tells you what you're pointing at, and that is way cool. And so I highly recommend that you get one of these apps and have fun with that. Also, we are approaching a time where there's more northern lights. The sun is getting more and more active. And just today I looked at the sun. There's a ton of sunspots. There's prominences. There was a flare today. And so you definitely want to get an app that tells you if there's northern lights in where you can see them. Now, here in Michigan, in southern Michigan, it's got to be quite a storm, solar storm, to see the northern lights. But I do expect that we'll be seeing northern lights here in Ann Arbor area this year and through the next 3 years. I think we'll have a good chance of that. So if I have an app that gives me a notification if the northern lights is going to be coming over the next day or 5 days. So I urge you to look up those types of apps too that let you know if there's a northern lights that you can see. And you just want to get out where there's no city lights. That's the best way to see the northern lights. And look north and make sure you have a low horizon with not a lot of trees. The best is over water. And around here, the best place to go would be the tip of the thumb, where you're overlooking Lake Huron, and you have a perfect horizon. I've seen northern lights there a couple times, and it's really good. And if you're in the UP, you're lucky because you're far north, and you have a wonderful Lake Superior shoreline that you can look at. But I'm just telling you that over the next 3 years, you're going to hear a lot more about northern lights and solar storms. So with that, I'm going to wrap it up, and I'll be doing it again tomorrow night, although the weather looks iffy, and I'll try to do some different things to keep it interesting. And so I want to say thank you, everybody, for all the wonderful comments, and look forward to doing another show tomorrow night. So thank you.